We're going to be working on lesson 21, writing and evaluating expressions. Multiplication and addition will be the two operations that we're going to be working with. And this is on page 239 on your workbook. So lesson 21, and this is page 239. Let's look at the example that they gave us. The Italian Villa restaurant has square tables that servers can put together to accommodate the customers. Only one chair fits along the side of the square table. Make a model of each situation to determine how many seats will fit around various rectangular tables. We're going to use these squares and rectangles on top of the page to represent the tables, and then we're going to use the ratio table on the bottom here to organize the information of how many tables we're going to be looking at and how many seats will be at each table. Let's look at the first table, the first square table, and here it's going to represent the first table. So the first table can hold how many people? Let's see, 1, 2, 3, and 4. And we're going to record that the first table can hold 4 people. Now for the second table, that it looks like a rectangle, we have 2 square tables. And now I am going to just add the 4 seats that we already had before, right there. And I'm going to change the color for the 2 additional ones that we added. So now with 2 square tables, we can add 1, 2, 3, 4, 5, 6 people. So I'm going to put a 6 right here. Now, if we add another square to the rectangle table here, 1, 2, 3 squares, which is 3 squares here, I am going to continue using the red colors for the seats that we had before. And I'm going to use the 2 different color, the blue one, to the new seats that we're able to add. So now how many seats do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So now we can seat 8 people. So let's go ahead and add another square. So now we have 1, 2, 3, 4 squares. And here we have 4 square tables. And we're going to figure out how many people can we seat. We already had 2, 4, 6, and 8. And I am going to color blue the new seats that we did, another 2. So that makes it 10 seats. So you can see 10 people now with 1, 2, 3, 4 squares. 4 squares, and we can have 10 seats. Now we're going to add 1, 2, 3, 4, 5 squares, and we're going to see how many seats or people we can accommodate. So the first 2, and then 4, 6, 8, 10, and then the new 2, or the new 2 for the additional square that we did. So hopefully you can see here that for 5 squares, 1, 2, 3, 4, 5 squares, we can accommodate 2, 4, 6, 8, 10, and 2 more. Makes it 12 seats. That will work for 12 people. And you can see the pattern. We can look at the pattern that every time we added a square table, the end seats were always the same. The only part that added 2 seats to accommodate customers was right here in the length for every time you added a square table. And I kind of did it with the blue color so you can see the 2 seats that were added every single time. So how can you represent that as an expression? If you think the ones that stay the same, it will be a constant change. It doesn't matter how many squares you add, that would always be the same. So I'm going to say for every square that you have, you're always going to add 2 seats because it is very consistent through the pattern. The end seats, they're always the same. Now, how are we going to represent whenever we have one table that we ended up with 2 seats, right? So we're going to say for every table, you ended up with 2 seats. So 1 table times 2 seats. And we can see if that works, right? Let's try it. 1 times 2, 2 plus 2 makes it 4. Let's continue the pattern, see if it works. How about if I had 2 tables and then times 2 seats plus the end tables? What would that give me? 2 times 2 is 4 plus 2, that makes it 6. So keep in mind the end tables is the number that doesn't change, but for every time you add a square, you added 2. So 2 times 2 gives you the 4. So can you start looking at the pattern now? The third table times 2, third table times 3, because there's 1, 2, 3 2's, right? Like 2 times 3. And then plus the 2 end tables, that does not change, is going to give me 2 times 3 times 2, 6 plus 2 gives me the 8. And we can look at the next one. The next one is 1, 2, 3, 4, right? There's 4 square tables times 2 on each side. Let's write that. 4 tables times 2 plus the end tables, because that did not change, that was consistent. That makes it 10. We look back and start looking at the number that keeps changing is the number of tables. And that is what we're going to do as a variable. They told us to use the variable t. So that is going to be t times 2 plus the 2 end seats that don't change, right? So that is going to be your expression. Let's try it with the 50 square tables. I'm going to rewrite the expression of how many tables times 2 plus 2. We're going to replace the t with the 50 times 2 plus 2. And if you want to think of, please excuse my dear Aunt Sally or PEMDAS to help you remind yourself that you do multiplication first. That can work. 50 times 2 is 100 plus 2 is 102. So this answer should be 102. Now let's do for 200, and you might want to think a little bit of estimation. How many 50s in 100? And that's 4, right? 450 makes 100. So you can probably say 100, 200, 300, 400. So your answer is supposed to be somewhere in the 400s. This is just making sense of your answer. So that way when you get a crazy answer, you can say, wait, that answer does not make sense, right? It always helps us. Now we're going to replace the t with 200 square tables times 2 plus 2. And that will give us 200 times 2 gives us 400 plus 2 give us 402. And that is close to the estimation that we did before we actually did the math, right? So the expression works. So what we're going to do is just write the expression that it says 2t, because that means multiplication, plus 2. The question that we have here, are there any other ways to think about the solution for this problem? What would be another ways you can think? I mean, this is where you start looking at the patterns and see which way did you look at the pattern to make sense of your answer. You might have other ways that you can think about, but this is just one way you can help you solve the problem. But one thing that we want to keep in mind is that it doesn't matter how the tables are arranged. The end tables always end up to be 2, right? the end tables always have 2 seats. And you might see other patterns, but that would be one of the patterns that you should have noticed, that those 2 seats will always be the same amount, and it didn't matter how many square tables you had. Next question. It is impractical to make a model of pushing 50 tables together to make a long rectangle. If we did have a rectangle that long, how many chairs would fit on a long side of the table? As we have always mentioned before, making pictures can be practical for a basic understanding, but when the numbers start to increase, that can be very difficult. So one of the things that you want to do is just I'm going to make just a very short model here because it's very impractical to make 50 squares. But keeping in mind when we learn that the end of the table has the 2 seats that never change, right? And we already know that 50 square tables makes 102 seats. If I take away the 2 end tables, that is going to make it 100 seats, which makes it to 50 seats on each side. So if you think about it, there's 50 here and 50 on the other side, so that makes it 100. So 50 seats for 100 seats. How many chairs fit on the end of the long table? You go back to the little model here that we recall saying that the end of the table has 2 seats, and we can just write it here. 2 chairs, 1 on each end. And this is just to kind of re-emphasize what we just said about subtracting the 2. We are continuing with page 240 on your workbook, and still on lesson 21. We're going to continue using the table that we did before to answer the next 3 questions. And this question that we have here, how many chairs fit in all, recorded on your table, it's still talking about the previous question that we had, where it was telling us how many seats we were going to be when we use 50 square tables, which was 102. Here we just have to make sure we say that in all, how many chairs fit in all, and that would be 102 chairs. So here we're going to write 102 chairs because it kind of refers to the other question that we did. Work with your group to determine how many chairs will fit around a very long rectangular table if 200 square tables were pushed together. We have the table here that kind of help us, that if it's 200 square tables pushed together, we will be having 402 seats. If we kind of explain it, we will say that there will be 400 seats on the long sides. Okay, I'll just make I'm a visual here and I like to actually be able to see it. So on this side from here to here, there's going to be 200 seats, and then from here to here will be another 200 seats, and then the 2 seats on the end tables, right? 400 seats on the long sides, and 1 seat on each end of the table. So we're just using words to describe mathematically what we found. If we let T represent the number of square tables that make one long rectangular table, what is the expression for the number of chairs that will fit around it? We already had discussed the expression before. We said that 2 times t plus the 2n tables can represent our expression. Now that would be one way you can write it. You can just write 2t plus 2. Or you can even say, well, I can put the 2 and then the t plus the 2. That also works. Those are all equivalent expressions.